Good morning friends. Welcome to Parnika's Tutorials YouTube channel. In this video, I want to discuss what is a binary tree and then I will discuss how to represent the binary tree using arrays and using linked list. So I request everyone to watch the complete video for better understanding. First let me define what is a binary tree. A binary tree is a tree where each node can have at most two children. What is meant by at most two children? A node can have 0 children or a 1 children or it can have 2 children. So, a binary tree is a tree where each node can have 0 children or it can have 1 children or it can have 2 children. Let me give an example for binary trees. Now, this is a node having the value A and we have a left child and we have the right child. Now can I call this as a binary tree? Yes, the node A having two children B and C. Now B is having 0 child and C is having 0 children. So it is possible. So I can call this as a binary tree where B and C are the leaf nodes, A is the root node. Now let's take that I am adding one more node which is a left child to the B and I am adding one more node which is a right child to the C. Still can I call it as a binary tree? Yes, I can still call this as a binary tree. Now let me take another example. Now this tree can I call it as a binary tree? Suppose let's take that it is having the values A, B and C. Now can I call this as a binary tree? Yes, I can call it. A is having one child, B is having one child and C is not having any children. So I can call this as a binary tree. Now let's take that I have a node A and it is having three children such as B, C and D. Now can I call this as a binary tree? No, I cannot call this as a binary tree. Why? The node A is having three children whereas a binary tree at most you can have two children for a node. So these are the examples for the binary tree and this is an example where the tree is not a binary tree. So now coming to the basics of the binary tree, we have the levels. This is, we will call it as level 0 and this is level 1 and this is level 2 so on. So always you can consider, sometimes they may consider that root node is at level 1 but usually the root node will be at the level 0 and the next one is level 1 and the next one is level 2 so on. Is it clear? So now we will discuss about how to represent the binary tree. In the next videos I will discuss how can I compute the height of a binary tree, what is the pseudocode for it one, all this one I will discuss in a separate video. In this video let me discuss how to represent the binary tree. Now we can represent the binary tree using arrays and using the linked list. Now first let me discuss how can we represent the binary trees using the arrays. Now let's take that array is a one-dimensional array. Okay. Now I have a binary tree. Let's take that A, B, C, D and then I have the E. Now can I call this as a binary tree? Yes, I can call this as a binary tree. Now how can I represent this one using the arrays? Now remember always one thing. The array index will start from 0. Suppose this is the array is A and always the array index will start from 0 and it will go to the up to size -1. Now always the root node will be at the index 0. So this one will be there at the index 0. So I will place the root node A at the index 0. Now the next node will be there at the index 1. Now which node will be there at the index 1? Now let's take that the parent node is at the index I, the left child will be there at the index called 2i plus 1, and the right child will be there at the index called 2i plus 2. Let me discuss again. If the parent node is at the index I, the left child will be there at the index called 2i plus 1, and the right child will be there at the index called 2i plus 2. Now here the I value is 0. So what is the 2i plus 1? 2 into 0 plus 1, which is equal to 1. So the B will be there at the index 1. And the right child will be there at the index called 2i plus 2, where I value is 0. So 2 into 0 plus 2, which is equal to 2. So this node is there at the index 1, and this node is there at the index 2. So C is there at the index 2. Let me erase this one so that we can do the rest of the things. Now, let me discuss again. Now, if I want to find the index of the node D, I need to check the index of the parent node. For D, the parent node is B. Now, if B is at the index 1, what about the index of the left child? It will be at 2i plus 1, where I value here is 1. So 2 into 1 plus 1, which is equal to 3. So D will be located at the index 3. So this is the index 3 and D will be here. At index 4, there is no right child. Am I right or wrong? So at the index 4, you will not have any element because this B is not having any right child. If it is having a right child, it will be there at an index called 2i plus 2, which is equal to 4. Now coming to the C left child. C left child is not having anything. So which is equal to 2i plus 1. If there is a left child, it will be there at an index called 2i plus 1, where I value is equal to 2 here, which is equal to 2 into 2 plus 1 is equal to 5. So there will be no element at the index 5 because C is not having any left child. Now coming to the E. E will be there at a position called 2i plus 2, where I value is equal to 2, which is 2 into 2 plus 2, which is equal to 6. So at index 6, you will have the element called E. So this is the way we will represent the binary tree using the one-dimensional array. You have to simply remember one point. If the parent node is at the index I, its left child will be there at index 2i plus 1, and right child will be there at the index called 2i plus 2. Then easily you can represent the binary tree using the arrays. Now let me discuss how can we represent the binary trees using the linked list. To represent the binary tree using the linked list, we will use the double linked list. Double linked list means the node will have 3 elements. One is the data and address of the previous node, and it will have the address of next node. So this is the structure of a node of a double linked list. So a double linked list means it will have 3 elements. One is that it will have the address of previous node, it will have the data, and it will have the address of the next node. Now how can we write using a structure? I think by this time you know how can I create a node which is a double linked list node. We can write it as simply strut node. Okay, you can write it as strut node star previous, you can write, and you can write int data if you are storing the integer values, and you can write the strut node star next. So this is the way you will create a node which is having the structure called a double linked list, which is having the previous address of the previous element, and it will have the data, and it will have the address of the next element. Okay, now how can I represent the binary tree using the double linked list? Now let's take that I have a, then here I will write a, okay, and I will write the address of, suppose let's take that I have, let me write the binary tree here. A I have, B is there, C is there, and D is there, and here E is there. Now this is my binary tree. A, B, C, and D and E. Now this is a binary tree. Yes, this is a binary tree. Now this binary tree, how can I represent using the double linked list? Here A is there. Okay, so I kept the data. Now address of the left child will be there here, and the address of the right child of A will be there here. So here you will have the address of the B, and here you will have the address of the C. Similarly, B will have its data, and it will have the left child. B's left child will have the address of the D. B will, here you will have the address of the left child, and D does not have any children. It does not have the left child, and it does not have the right child. So here you will have the values called null. Okay. Now similarly, C is having the right child. So if I make it as a double linked list node, it will have the, let me write here, it will have the E and null and null. Why it will have the null and null? Because it is the leaf node. It does not have the left child and the right child. So I have kept the values as null. Now coming to the A, left child is there, right child is there. B having the left child but it does not have the right child. So you will have the value here as null. And similarly, C is having right child but it is not having the left child. So here the value will be null. Okay, so this is the way you will represent the binary tree using the linked list. So I hope with these examples you have understood what is a binary tree and how can we represent using the arrays and using the linked list. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.